Universe. This is Marilita Sanchez Hermoso from Bachelor of Secondary Education, major in Social Studies, Set B. And this is my output on SSC 106, Geography 2. Good morning, class. On this day, we will tackle about location, direction, and time on map and Earth. Here is now our learning objectives for today's lesson. The students will be able to know how to locate places on map and Earth or globe by means of geographic coordinate system, and how to read time associated by the GMT, UTC, and International Date Line. To help us locate places on the Earth's surface, we use a coordinate system. And this coordinate system is like placing a giant grid over the Earth. This grid has lines extended from the east to west, lines of latitude, and lines extended from the North Pole and to the South Pole, which called lines of longitude, which is the two measures used in the geographic coordinate systems. For the information of everybody, latitude are imaginary lines that run on the west and east direction parallel to each other. The longest latitude is called the equator. It runs around the center of the Earth and divides the Earth into northern hemisphere and the southern hemisphere. Latitude measures the degrees and the equator marks at 0 degree. Latitude north from equator go up in numbers from 1 to 90 degrees until they reach the North Pole. Latitude south from the equator go down as negative number until they reach negative 90 degrees, which called the South Pole. While the longitude is imaginary lines that all start at one pole, they move away from each other until they get to the equator and they start closing and meeting again at the other pole. The central longitude is called the prime meridian. This line divides the Earth into western hemisphere and the eastern hemisphere. Like the equator, the prime meridian mark a 0 degree longitude east of the prime meridian go up and emerge to 180 degrees of east, and longitude of west of the prime meridian go down as negative numbers to negative 180 degrees. Now class, let's locate places on a map using geographical coordinate system. The latitude and longitude position in any places of Earth is called coordinates. The latitude shown first and the longitude shown second. So imagine look for measuring place with the coordinates of 30 and 31 degrees. We will place with the latitude of 30 degrees and longitude of 31 degrees. And where these two lines met? In the place of in the Great Pyramid of Giza, Egypt. Another one example class, with the coordinates of a latitude of negative 3 and longitude of negative 59. And this line met on the place of, yes, you got it, Amazon forest. As you can see class, each place of Earth has its own unique set of orbits, make up a latitude and longitude. If you know where coordinates in place, you can find it on a map using geographical coordinate system. Now let's move to the GMT or the Greenwich Mean Time. Like so many historical artifacts of science, GMT is Western-centric, but it nonetheless was adopted globally. In modern times, with a greater accuracy that atomic clocks allow, GMT has been replaced by Universal Time Coordinated or UTC. However, the prime meridian that was established through Greenwich for GMT remains the base of UTC. So GMT is the reliable time scale. Lines of longitude mark time zones as the bird rotates on its axis only one half of the Earth facing the sun in a given time. That's mean when it's nighttime on other hemisphere while day on the other hemisphere. And this means that people in different places in the world live in different time zones. In GMT, determine first if we are east or west of the prime meridian. If we are in the west of the prime meridian, the GMT minus the time at the prime meridian. If we are on the east, the time will be after or plus GMT. For example class, as the Earth rotates 360 degrees in about 24 hours, which means 15 degrees in 1 hour, or 1 degree in 4 minutes. When it is 12 noon at Greenwich, the time at 15 degrees east of Greenwich will be 15 times 4 equals to 60 minutes. So 1 hour ahead of Greenwich time. Or plus it, which means it is 1 p.m. But at 15 degrees west of Greenwich, the time will be behind GMT by 1 hour. Or minus it. It will be 11 a.m. Here's another thing. Greenland has a minus 1 hour GMT from the prime region. If the time is 4:17 GMT, it will be 3:17 in the eastern Greenland. Also, in Oslo, it has plus 1 hour GMT from the prime region. So, if it is 4:44 GMT, then it will be 5:44 in Oslo. Another example class. In Wellington, in New Zealand, it plus 12 GMT. That means that it's 12 or 12 times zones ahead of London. So if it is 7 o'clock in the morning in London, that means that it's 7 o'clock at night in Wellington. Let's look at a country like Jamaica. They are minus 5 GMT. That means that there are 5 hours behind London. So if it's 7 in the morning in London, it means it's 2 in the morning in Jamaica. UTC stands for Coordinated Universal Time. This is the primary time standard in the world, and the standard after which the entire world regulates its time. Your clock is regulated by the Coordinate Universal Time Standard. UTC is not a time zone, even though people use it as one. Again, UTC is a time standard. GMT, an abbreviation for Greenwich Time Zone, is the time zone that observes UTC plus 0, time that exact UTC time. The plus sign is known as the offset from the Coordinated Universal Time. It tells people by how many hours their time is offset from the UTC. For example, Samoa has a time offset of UTC plus 13. Baker Island and Holland Island, on the other hand, have a negative offset of UTC negative 12. The differences in time between the various countries on Earth can be huge. Universal time coordinates one of several names for the 24-hour time, which is used throughout the scientific and military communities. Coordinated Universal Time is a time standard based on International Atomic Time, with elapsed seconds added at irregular intervals to synchronize with the Earth's rotation. UTC is closely related to Universal Time and Greenwich Mean Time, and with an informal or casual context where sub-second precision is not required. It can be used interchangeably. Time zones around the world can be expressed as positive or negative offset from UTC. Lastly, for the international dateline, the international dateline or IDL is an imaginary and arbitrary line on the Earth's surface that runs from the North Pole and to the South Pole. So when you cross the international dateline, the day and date change. The dateline is a line that generally follows the 180 degrees meridian. The international dateline, we turn our calendar back a full day if you're traveling east and forward full day if you're traveling west. Example, if you are going east from Siberia to Alaska and it is 8:30 p.m. Monday, just before the cross the international dateline, then it will be 8:30 p.m. Sunday on the other side. Thus, if we're going to east from Tokyo to San Francisco and it is 4:30 p.m. Monday just before we cross the international dateline, it will be 4:30 p.m. Sunday on the other side. Each new day first begins on the international dateline and then extends west as each time zone reaches midnight. An airplane can fly from Tuesday into Wednesday and then back over into Tuesday again. It's possible to travel around the globe and be in the same day for 47 hours. A little trivia class, the entire Earth is on the same day for only 1 hour each day. That's all for today's lesson. Any clarification, suggestion, question, or reaction? None so far? I hope you've learned, class. Thank you for listening and cooperating. Goodbye, class.